thank you for having me, and it sounds like you've got a very interesting program that's going on here this week. And I'm not used when I'm talking to a group of scientists to see all these women faces. So it's great to see how some things have changed. And what I want to talk to you about today is another aspect of the science community that I hope is changing, which is our attitude about everybody outside the ivory tower, and what's needed to actually get our science used. I think if you look at the state of the science endeavor right now, it can be rather terrifying to see the degree to which science is ignored. From climate change deniers on the right to anti-vaxxers on the left, we have a lot of people in our society that don't buy into the idea that we as scientists are actually able to understand what's true. And I think we can take a lot of reasons for that, and there's a lot of issues in a lot of directions. But I think the common idea within academia that our job is to do the research and figure out what's true, and it's somebody else's job to learn how to implement that, has contributed to this divide that's coming to damage our country. And a lot of people talk about it in terms of issues around science communication. You can find a lot of books out there that will tell you what bad communicators we are, and all the things that we should do differently. But communication is in of itself not enough. If you look at this issue of communication versus what I'm calling activation, because I don't know what else to call it, communication implies one direction, that I have information that I'm providing to someone else, and that it's our job to understand how to explain our knowledge. That is, in fact, an important thing to do. We are seeing people don't understand a lot of what we got. But I don't think it's enough. I think when I'm talking about activation, I'm implying bilateral communication, that we're actually exchanging information to better understand the problem that needs to be solved. Because there are probably factors in the actual implementation that didn't fit in our nice experiment. And there are more things that need to be considered than what we have, and just taking our information and throwing it over the transom, or even handing it through the pass-through and trying to make sure that it's received on the other hand, isn't enough to empower the use of the information. So what I want to talk about today is what it is that needs to be done for society. And this isn't all from us, but we all, as scientists, we have to participate in this interchange. Because right now we have academia over here, and we have policymakers over here. And one of my friends in the climate change space calls it a demilitarized zone in between. We don't know how to fill that space and make the connection happen. So I want to start by looking at what are some of the challenges to science activation. Where do we fall apart in making this happen? And you've probably, this is actually from the March for Science, right? And it's a joke, because that's not the way other people are undertaking a lot of the decision making. But it implies one of the biggest issues is cultural differences about how we communicate. And I want to talk about why we communicate the way we do within science, rather than just saying it's not working on the outside. Because plenty of people will tell you what's wrong with what we do, but you need to understand why we are who we are. It's not because we're not human beings. I don't know if you guys know, you guys must know the XKCD comics, right? The scientific idea that you have to test that the plural of anecdote is not data is not natural to the human condition. We have lots of inherited, evolved tendencies in the development of rational thought that get us to jump to information, that use the anecdote to be able to hypothesize quickly. All of those are things that helped us survive, as our intelligence was the only thing we had going for us. And we've had to work against it within the scientific process. I mean, let's think about what it is that we do when we come up with some idea, right? So you guys are in cyber security and climate change? Okay, right? I'm probably going to talk more towards the climate change ideas because so I'm a seismologist, if that wasn't obvious. I spent 33 years with the U.S. Geological Survey as a research seismologist and then gradually becoming more and more engaged in working with policymakers and getting the information used, and only completed my federal service a couple of years ago. Thank heavens I'm not a federal employee now. And have been started my own center, and I'm also still at Caltech. So I'm coming out of that hazard science role. And when we're trying to make patterns, just like all human beings, we like making patterns, and we see some relationship. Let's suppose we see a big spike in electromagnetic radiation just before an earthquake. This actually happened before the Loma Prieta earthquake in 1989. We notice a coincidence. We then have to figure out whether it was just a coincidence, because we really do know the plural of anecdote is not data. You need to see whether or not it's a repeatable thing. So we go and test whether it's coincidental. And by the way, the electromagnetic spike turned out to be completely coincidental. We never saw it with any other earthquake. But we find something that does indeed hold up. We see a pattern that seems to be there over repeated things. And then we create a model consistent with our other known phenomena to explain that result. Right? So we have an observation, we create a model to explain it, and then we test the model by making predictions from it and see whether or not it holds up in repeated situations. We then think we actually got something that holds together. We present results to the colleagues. We give lectures, we give talks at professional meetings, we write it up in a peer-reviewed journal, and we get ripped to shred by our colleagues, right? That is the scientific method, and it is absolutely necessary because the easiest person to fool is yourself. One of the things that we know from human evolution is this concept of what's called a confirmation bias. When we evolved our intelligence in a very hyper-socialized setting, we needed to make sure that we weren't the only one going out in the hunt and everyone else was staying safely back in the cave. We had to win arguments. So our evolutionary success did not come from being right. It came from being successful in our arguments. So we have this thing that's called a confirmation bias, that we are more accepting of data that matches what we already believe and more critical of oppositional ones. It's sort of an internal yes man. So it means that the person that's easiest to fool is ourselves. And the scientific method has been evolved to try and actually overcome the human nature and find something that's actually defensible. And so it is fundamentally important and a critical part of the scientific process. It is what research is. It can't do it by yourself. But it has implications for how we talk about things. When you go to discuss the result of your research with your colleagues, you will never, ever give the result first, because they'll jump down your throat. Well, what did you think about this? Haven't you considered that, right? Instead, we lay out the backgrounds. We describe our methods. We very carefully discuss our uncertainties, right? Because scientists and engineers are the only people in the world that like uncertainty. We think it's really important, right? And before we give a result, we explain all of that so that the person who is listening to us will understand we really did our job. We found something that was actually true, and they can share in our excitement. The problem is that nobody else speaks like this. If you look what goes on in a newspaper article, you give results first, then you say why it matters, and only after you've done all that, maybe you talk about the background. Right? So when we take our approach that's necessary for talking to our colleagues and talk to a non-professional, and we really get those uncertainties discussed before we give the result, people have heard that we're uncertain and they aren't listening by the time we get to our results. Right? So it is a fundamental difference in styles of communication, and we need to understand why we do our way and when it is appropriate. Right? If a policymaker is coming to you as the research expert at UCLA, they don't need convincing that you know your answer. They come to you because they believe you have the answer and they want to understand what it is. So we've got this one really significant a cultural difference in how we carry off our communication. Another aspect of this is we have learned to avoid stories. If you try to explain your colleague a result with an anecdote, they're going to say, well, that's ridiculous. Haven't you tested it? Just because one person did it, so what, right? So we actively avoid stories. And the problem, of course, is that's how everybody else makes decisions. People make decisions from a place of empathy, and the story gives you a connection, gives you an ability to understand where it fits in with you. So we have these, and then we have this whole thing about uncertainties before results. And it's not just that we talk about uncertainty and they hear it the wrong way. It's really fundamental, again, emotional reactions to the whole concept of uncertainty really plays in here. There's a very interesting book for those who maybe haven't heard of it called Risk Perception. It's by Paul Slovic out of the University of Oregon. It's getting a little long in the teeth now. I think this is probably 15 or 20 years ago. But he looked at the psychological reasons of how people process risk. And it gets back again to our evolutionary imperative that we are more afraid of the hidden predator. The predator that you can see is one that you can avoid. The idea that there's something hidden and you don't know it's there, that is a greater risk to you. So when you look at the factors that make people afraid of something, being unseen, uncertain, or perceived as unknowable, all substantially increase our perception of the risk involved. You know, as an earthquake scientist, I'm particularly aware of this because earthquakes, you don't know when they're coming, they're unpredictable, you can't see them from under the ground, and there's a perception that much of the shaking, it's unknowable where the shaking's going to be, right? And part of this is our fault as communicators. You know, an earthquake happens and the media runs to the seismolab. Have you ever wondered why? I mean, it's like, why should people come and talk to a seismologist because there's just been an earthquake? Knowing the name of the fault does not help you rebuild your house. But it does say somebody understands this. I give it a name, I give it a number, I give it a fault, I put it back in the box that says somebody understands this. One of the things that often happens, though, is, you know, the media get out there and faced with a bunch of Caltech scientists, oh my God, how do I get these guys talking, right? So they figured out that one of the ways to get a scientist talking is to ask them, what did you learn, right? We're always excited about what we learn. So the standard question is, what did you learn in this earthquake? And the literal-minded scientists think, oh, they want to know what we learned. So we start talking about all the things we didn't know in this earthquake, the things that surprised us. The fact that 95% of the damage was, told you so, that never gets communicated because we think they actually want an answer to the question they asked instead of recognizing that what that was a prompt to get us starting. And I've actually now started quite explicitly going, well, you know, most of it wasn't a surprise. You see that damage? Yeah, that was what we expected. We told you that that was the bad type of house. And that type of answer I'm trying to help people understand, not just you better retrofit your house, but that this is an understandable process because that is a fundamental piece of reducing the fear. Sorry, that was a bit of a distraction. The other aspect of it, though, is the unpredictability and the idea of randomness. And if we go back to thinking about how we created, you know, the human brains evolved, we are evolved to reject randomness, right? Back in that primitive world, if you could hypothesize the connection between the waving grass and the predator hiding within it, you're more likely to survive. So we are very strongly wired to create patterns, especially when faced with risk, right? And when you made the connection between the mushrooms you just ate and the gastrointestinal distress that you were suffering, that was a very successful use of pattern making. And again, it becomes an important feature in our evolution. So we are wired to reject randomness and find patterns. And let's be honest, as scientists, that's what we do, right? That's what we are, is trying to find those patterns and make those models that we can actually predict this stuff. The problem is we find patterns even when they don't exist, right? So when we create constellations and stars, But especially when you get to natural disasters, we actually go farther than that. Have you ever thought about the word disaster? It actually first shows up in Shakespeare, ill-starred. It reflects the belief that your fate is written in the stars, and this happened to you because it was fated that you were going to be that way. And it reflects our inability to accept the random timing of the big natural disasters, right? Lots of people lived in the shadow of Pompeii without actually getting hit by that eruption. Why did that one generation get it? Well, it must have been the gods. So you had a Roman philosophy that actually, Vesuvius would erupt when Venus cheated on Vulcan and he had a male hissy fit, right? And you just happened to get in the way. Most of Western civilization, though, as we know it, came out of more of the Judeo-Christian tradition, who looked at this and said, no, God's good. God's somebody you can make a covenant with. That means if you got hit by that disaster, it must be your fault, right? And you have this whole strong tradition. Every culture in the world has a flood tradition. It's only the Judeo-Christian one that makes it the victim's fault, that it was done for the punishment of sins. And so this very much falls within Western culture, is that there isn't such a thing as randomness. When it's random, it's really about God punishing you. And of course, putting it on God keeps it from being really testable, which allows you to keep your hypothesis going for quite a bit longer. And it kept going in Western society actually until an earthquake in 1755 that destroyed the city of Lisbon, which at the time was the fourth largest city of Europe, was fabulously wealthy from all of the minerals that were coming from Brazil. The earthquake happened on the morning of All Saints' Day, which in this highly Catholic country meant everybody was in church, or at least all the pious were in church. And all of the churches collapsed because it was at 9:40 in the morning, the earthquake. And then the whorehouses built out of wood up on the hills were basically spared. So it sort of caused this philosophical problem. And it's interesting in the intellectuals. There's this whole debate that goes on between Voltaire and Rousseau, and Voltaire rejected the idea that this was God's punishment and was labeled an atheist because nobody could imagine how you had God without having him have that level of control. At the more local level, of course, Catholics saw it as proof that they hadn't been hard enough on the Protestants and set up a bunch of more executions. The Protestants saw it as proof that the Inquisition was actually was clearly the devil's work. And in fact, the Dutch Parliament, which was Calvinist at the time, when asked for aid for Lisbon, actually said, God has decided how much the Lisbon should suffer, and it's not in our role to change what God has decreed. I'm taking a little bit of diversion on this just to help you see what a fundamental issue this is within human society. It's not just Western. If you go into the Eastern tradition, they did the same thing. There's a book from 200 BC that tells how earthquakes and all other natural disasters happen because you've come out of balance between the earth yin and the air yang. So if you have too much yang, you get hurricanes. If you have too much yin, you get earthquakes. Too much yin might be because the emperor's about to die, or the ministers have usurped his power, or there are women in government. This is all written in this book from a long time ago. Not directly believed, but still an influence. It's really interesting. If you look at the Tong Shan earthquake in 1976, killed over 500,000 people, basically the two buildings standing out of this whole city of 1.5 million people. Of course, they didn't say this was caused by problems in government, but Mao died 6 weeks later. So all of that cultural norms towards saying that the emperor's going to die is the cause of the earthquakes. The earthquake happened. Mao's nowhere to be seen. He was unable. I mean, he was unconscious at that point, and the rumors really got going. You then had earthquake predictions made in half of the provinces of China. One estimate is that 500 million people, 500 million people lived outdoors for the next month. Of course, it was August. It was an easier time to do it. And then once Mao died, the Gang of Four was overthrown just a few weeks later. And the actual indictment that was used against them used the same words that were back there in that 200 BC text about the ministers usurping powers. I mean, they didn't say the emperor, right? But they said that they were usurping Mao's powers, and especially Jiang Qing focusing on that whole problem of women in government. So this is the background from which we're doing this, and I just realized I did a little bit out of order because this gets back to that same idea, information reducing fear. I tried to look for seismologists doing press conference after earthquakes, and I found them from a lot of different cultures. And but as I already mentioned, this is because we're reducing that fear of the randomness. Let's get back to what it is, to a more general science idea. Whenever we're discussing probabilities and uncertainties, we are talking about randomness and the fact that it can't be predicted. And that means we are focusing on the part that makes people more scared. Right? And when we do that, we tend to reduce the level of action that people are going to take. Because if people hear that you don't know, what's the worth of doing it? You look at the climate change issues. What's happened as climate change began to be discussed, 20 years ago when we first started talking about it really publicly, or 25 years ago, there was a lot of focus on the uncertainties, trying to explain why we think this is really true at a time when the data wasn't yet so solid. And that message of uncertainty is the one that stayed around. And it's important, the shift that's been happening in the last few years and the willingness of the scientists to just be a lot more absolute in our statements about, yes, this is related, yes, this earthquake, or not this earthquake, yes, this hurricane was probably stronger because of climate change. I instinctively put in that word probably. We never want to say those absolute things. And we shouldn't be absolute if we aren't sure, if it can't be proved wrong. But for us, when we discuss the uncertainties, if we're trying to show that the uncertainty is lower than 5%, that's our way of saying it's certain. That's not the way it's heard out of the larger issue. That's where we hear that we are uncertain. As I said, it's really important not to do it when you aren't completely certain. This is an interesting piece of data that was developed by some communication specialists that look at crisis communication. And this is just news reports about salmonella contamination in peanut butter. You might remember, I don't know if you remember this or not, it's about a decade ago. There was contamination, there was salmonella showing up, the peanut butter was being implicated. The people at the company were saying very definitively it's not the peanut butter because they thought were going to get away with that. They thought it was going to be true. When in fact it became obvious and they had to acknowledge that there was a connection. Then you have a huge spike in the numbers of stories going on, and you create even a larger message about how people were wrong, which again increases the fear of what's going on. Okay, so the next issue that I think is getting in the way of science activation is how we go about talking about our science. When you think about it, where is the primary way in which a scientific result gets communicated to the larger community? One really common way is through our big meetings, right? Through our big scientific conferences. So the American Geophysical Union is the one that I go to. They probably have 15 or 20 press conferences through the time of the event. There are about 30,000 scientists that show up at this meeting, right? And what's being presented here is the great exciting paper at that conference. Well, why do you take papers to a conference? If it's already published, you don't give it at the conference, right? You're giving the results that you're still working on. And one of the reasons that we do it, the reason it's always justified, is that by presenting it to our colleagues, we get them to criticize us and tell us what the problems are, right? And that is a really important role. It's an expansion of that peer review process, not just when it's all written up. Here's an early stage. You present the results and you get people to trash you and you hear things and you can go and remind you about some other paper that was done, you investigating in more detail. In other words, what we are giving at our conferences is not peer-reviewed science. It's very early in the process. And even once you've got a peer-reviewed paper, you know, there's probably a pretty good chunk of the community when you put out your paper, they're going to go, that's wrong, I know it's something else. And they're going to go and do a challenging paper, you know, come up with some other data, at least if your paper was interesting, right? And so it's only after there's been a dozen papers that the result is really pretty solid, especially on the more important things. So we are only talking about our results when it's not yet settled. And that means that next year there's probably another paper going, oh, that one was wrong. And that this is back to what are we communicating to the public? We are communicating that the scientists don't know what they're talking about. One says this and the other one says that. Who knows which one you're supposed to listen to? Once it actually becomes consensus, who talks about it? Because the reality is once it's consensus, we are bored, right? We're only interested in the ones that aren't settled yet. If there's nothing to argue over, why are you talking about it? And so that gets back to this demilitarized zone. Once the science has reached the point that it really is ready to be used, the academic community is no longer engaged with it. But what we've got are a series of papers that are not in a form that a policymaker can really understand and figure out how to connect to what they're doing. And I think this is a core problem. I'm not going to put it all on the scientists, right? We aren't paid to do this. I know within the U.S. Geological Survey, I tried to create some programs, and I was able to get the science better used. But they were really seen as one-off experiments because we were authorized by Congress, because we actually, back when Congress got things done, to do a specific job. And we are explicitly prohibited from using that money on something else. This is why they can't just go and take some money already appropriated and use it to build a wall, because Congress has to authorize the use of the money for what you're doing. And in general, the science organizations are authorized to do the research. They do not have a discussion of it going farther. And that is, so as a societal problem, it's just we haven't populated that space. For those, well, how many of you are from California? Oh, so not. How many of you have heard of the Partfield earthquake prediction experiment? Okay, so this is also getting old. This was a time when we came up with a prediction experiment. We said the earthquake would happen by 1988, plus or minus 5 years. It actually happened in 2004. We were able to disprove this theory at the 95% confidence limit. How did it even get out as a public thing? It was actually a shared confirmation bias. And that is another important problem that we face, that we, you know, as an individual, I have this, you believe that, we can fight about it and come up with it. But if the whole community is sharing some confirmation bias that isn't actually true, we can really be caught in there. And so this gets back to, so this whole thing of settled information, or consensus information, how do we do it at that point? One more example of doing it really wrong, think about what's happened in public health. You know, we have the food pyramid that was put out in 1992. Make sure you eat lots of bread, right? And make sure that you don't have any oils, right? And even at the time, right, they were saying that it was saturated fat that was the problem. You both, you know, the research showing that in fact carbohydrates could really be the problem were being suppressed. I mean, there's a lot of things where the whole thing with the sugar industry having potentially funded, studies to try and push it in this direction, and then compound it with saying people are too stupid to understand the difference between saturated and monosaturated and unsaturated fats, so we're just going to say they're all bad, right? So this is a really big mistake. There was a combination that the science wasn't actually settled and treating the public as too stupid to handle more complex information. But I think you can argue, and people have been arguing, that this has contributed to a significant rise in obesity within the country. They're trying to move on, but they don't dare give up the pyramid. So now they're going up, well, we really have a healthy pyramid. And if you start looking at the differences, you'll start noticing you got exercise at the bottom, right? And they try to put the good fats in here. But it's also a way of trying to pretend that you haven't actually changed it that much, because of that problem of once you start really changing your story, you undermine the credibility of all of it. So I'll add one more challenge to us being able to do that. And that is the strong belief that you only are supposed to talk about your own research. Right? Now, especially because we're giving the communication through those press conferences at the press conferences at our big annual meetings, and the reason we do that is because by getting news coverage, your university looks better, so you've got your whole university pushing you to do that, and then the person who actually did the research is supposed to be the one that gets that. And one of the things is, if I had stayed at the USGS, I would never have been allowed to talk about climate change, because I'm a seismologist. I'm not an atmospheric physicist or atmospheric chemist. I shouldn't be talking about that in any public way. And the problem is, of course, what we're doing, focusing on those details and only on what our work is, we are never giving that information that turns it into a more usable form. And sort of as an extreme example about this, let's imagine you saw somebody standing in a busy road with cars going by. What would you do? Hopefully you'd yell, "Hey, there's a car coming," right? Get out of the way. You wouldn't yell, "Hey, remember, force equals mass times acceleration." It is the science that's relevant at that time, but it's not the information that they need. Right? So, how do we go about getting the car is coming instead of Physics 101? I want to spend a moment to tell about one example of how I have tried to deal with this. And I don't know how many of you are aware of this. While I was still with the U.S. Geological Survey, I ended up negotiating a plan with the mayor's office for the city of Los Angeles, and I spent 2014 in the mayor's office. So it was officially an agreement between the USGS and the mayor's office. As I said, what an interesting experiment. Once it got done, I said, okay, that was enough, now come back and do real science. But in the process, I was there to help them both understand the implications of the seismic risk that we were facing, but also to see how that connected with all of their other issues towards creating a shared plan. It was astonishingly successful. There are over 15,000 buildings that are known to be dangerous in earthquakes that the city is now mandating being retrofitted. We passed the legislation in 2015. Over half of those buildings have entered into the process already. About 2,000 have been completed. The others are either in construction, in permit, plans being reviewed. Quite a few other things that happened as well, but this is probably the biggest one. There were also issues around water for earthquakes. I don't know if the city of Los Angeles gets 85% of its water from outside the region in 4 aqueducts. These are the blue lines on this map. Every one of them crossed the San Andreas Fault within the sections that are expected to break in the next big earthquake. The plan has been, so we lose an aqueduct, we've got 3 others. The reality is, to be a magnitude 8, all of them will break at the same time. Right? And nobody had dealt with it really until we did this. There's also an issue that the pipes in the ground are very brittle. The city has made a commitment to a seismic resistant system. They have now replaced a significant number. When they insisted on these pipes, at first there was only one Japanese company that could make them. There are now 8 others because the city stuck to their guns and said they would only do that. The prices are all coming down. We've got a much better water system about it. There's other things as well. I just wanted to very quickly say, by getting in there and really connecting the science to the policy, we were able to get the biggest change in seismic safety that we've ever seen. And we did it unanimously. Every city council ordinance that was required, there were 5 of them, they all passed unanimously. It ended up taking a year, but they all got done. A year after 2014, it was the end of 2015 where it was done. And then now other cities are wanting to do it. They saw that this didn't hurt Mayor Garcetti. He actually is looking pretty good, right? And so other jurisdictions are starting to do it. One of the reasons I completed my federal service is the Southern California Association of Governments asked for help with the other cities, and basically the USGS is like, well, we did that once, why are you doing it again? And we've ended up with the cohort process. We got them all in and engaged, and We have 3 cities that have passed retrofit. Oh, I should have updated this. Moore Park has now passed retrofitting legislation along with West Hollywood and Santa Monica and Los Angeles. We've got another dozen that are working on it at the time. Oh, Beverly Hills just passed. Pasadena votes this month. I mean, it's starting to go on through. And also some other actions, especially about water issues that are being taken by different cities. Okay. Running through those results, I want to get really more importantly to why is this working and what is it about the system, what happened here that's allowed us to get the science used and move beyond the traditional problems. One of the big issues is that I based the whole thing on a scientific scenario. So there's something called the Shakeout Scenario that had been developed with USGS. It's a picture of what the big San Andreas earthquake will be like. A little movie to entrance you here on the side. This is actually showing ground motions overlooking Palm Springs. Over here, you'll see how it goes all the way up over the map. The ground motions are really large, and there's this whole scientific study that completely describes what the impact of all of these are going to be. And as we did the program, we focused on this. Rather than saying, oh, there's this earthquake problem with all these different things, and there's the probability of this and the probability of that, I said, here's this earthquake that's going to be really bad. It happens often enough to be worth acting on. The probability is 100%. Just give me enough time. Right? And I wouldn't say what the probability was in some arbitrary time period. Needed to focus on the fact that it was inevitable eventually. And I think that that was a really important part of the process. One of it is that the scenario is a story. In fact, the public version of it, we do it as a story. We start 10 minutes before the earthquake and go to 6 months after, and use that to describe the results through a narrative. Right? It avoids the probabilities. We don't talk about, where you're going to have what shaking. We talk about the fact that it's a consensus that it will happen, and that the results were all things that were a consensus, right? And that's a really important part. We had huge fights to agree on what would be going in there, right? But we did it in private. We didn't do it out for everybody else. And we got it through a complicated review process. And then we had this document that we could get everybody to say, yes, that's a plausible earthquake. And actually, one of the big challenges is we're used to saying, a plausible earthquake, what do you mean? I don't know if it'll happen. And in fact, I can say that the earthquake we describe here will not happen. We had to make so many assumptions that some of them are going to be, the next earthquake that happens will be something different. Right? But if it were to happen, nobody'd be surprised. This is a way of presenting what we already know in a more empathetic, connectable way of having the information. Another important part is that we really focused on the financial outcomes rather than on the life safety. Life safety is triggering fear, and one response to fear is to not think about it, right? I actually think that's a big issue with climate change. We have said, here's this horrible problem, and we haven't said an obvious solution, because that's not our job, right? Our job is to describe the science of what's really happening to the atmosphere. The solutions are political. The solutions are how we choose to do energy and a lot of other things. So we give the problem without a solution. And that's something that the social scientists tell us is a great way to get people to run away, because it increases anxiety and reduces action. If instead, and this is one of the things I did with this project, here's the problem. Actually, and I didn't say I said, what should we do about it? Let's talk about it. What are things that could make a difference? Do you think this, could this be accomplished? If you could do this, we would reduce these number of deaths. If you could do this, we would have another 150,000 people that don't lose their homes, right? Those sort of discussions. But as long as we're focused on the awfulness of the disaster, we increase our fear and reduce anxiety, and instead we need to talk about the financial aspects of it. Another really important piece in here, and it was a challenge, is make sure we understood the difference between science and policy even as we work together. And that as scientists and engineers, our job was to make sure that the elected officials understood the implications of their decisions, right? That's what science does. It says if you do this, this will be the outcome, right? But it's still the policymaker's job to make the decisions. Nobody elected me to go and change LA laws. They elected Mayor Garcetti for that. And I had to accept that it was his decision to make. I might not agree with it. And one thing is the way we did it, I had the option of saying, here's the mayor's choice. I don't agree, think it's going to work, but this is his choice. I could have said that. He knew that. That helped influence his decision. Right? But in the end, it was still his decision. And I don't think I can emphasize this enough because, as you know, again, do climate change. We see how awful it is. We understand that it's potentially an existential threat for our society. That's a bigger thing than I ever managed out of any earthquake. And we think that, you know, we have a lot of things we think that could be done. But, and to provide people the information to understand how to use the science to make decisions, we have to come up and say pretty close. And then once, I'm going to go back to the earthquakes because it's the easier thing to say. I know what those bad buildings are going to do. I know the likelihood of the earthquake that's going to be coming through. I think they should be retrofitted, right? But that's not my decision to make. I need to say, if you retrofit, you're going to have 150,000 households that don't lose their homes. And it will cost you this amount now that will save you that amount later. And then but I have to get it to that level of detail for the elected official really to be able to understand what the implications of his decisions are making. So we have to get so close to the policy science line that as voters and citizens, we will have significant opinions about it. But that's not our job. And it's how to get up there where the science is fully understandable without taking other people's decisions away from them. Because it's not just the elected officials, all of the stakeholders. There were a lot of people involved. I had 130 meetings in 10 months at City Hall, if you want to talk about being tired. Especially coming from a place like Caltech where I don't usually have to worry about anybody even looking at me, let alone trying to talk to me, which I like, and getting in there and doing this several times a week, and then sitting in these meetings and working through various details. But by doing it, the stakeholder, the Building Owner and Management Association sat with us and really looked at what the issues were and what retrofitting would cost and what it was going to gain us. And by the time we got to the point that the mayor said, I'm going to, mandate retrofit of concrete buildings and it's going to cost the owners of those 1,500 buildings a total of $1 billion, the Building Owners and Management Association stood with the mayor and agreed, because they had really looked at what the implications would be. And part of it was like, I don't want to have to be made to do my building, but I damn well want to make sure my neighbor has to do his building. So I'll put up with it happening to me. But that stakeholder aspect, when people are engaged in creating the solutions and they can see their fingerprints on it, even if it's just a tiny bit of the solution, they're more likely to support it. And this creates people that are going to go and advocate for your results. The other part I gotta say is just that relationships matter. This didn't happen out of the blue. This happened because we'd been working with various elected officials across the city for decades, and they had people that they could trust. And so part of the process is how to spend time providing information that maybe you won't see a result to the elected officials, because then they'll start learning that you're someone that they can trust and that they can turn to for the information that they need. And your credibility as a scientist, your reputation is big. It gets people to listen to you. And we haven't completely squandered that in this country yet, and we need to use it as much as we can. So I'm gonna end with my last object is that we need to do a better job of supporting researchers who do this work. I mean, the reality is if you spend time doing this and when you're up for tenure, they're going to say, why are you spending time on that and not writing the papers that you really should be caring about? And it's a shift that I'm starting to see. I will say I'm actually really extremely encouraged at the degree to which we are seeing that shift. In fact, so I just last week taught a class at Caltech with 20 some students in which we went through a lot of this sort of stuff And I had an ex-elected official staffer who worked with me, helping them really understand what is it that, how does government work? What are these, how do you go and handle this meeting? All of these practical things. They ended up going and getting visits with elected officials at both City Hall and with state and federal. And the fact that Caltech supported this time and is wanting to continue the class on a regular basis is something that I would never have imagined possible 10 years ago, because it had just not been understood. And I do think it's climate change is helping drive the discussion. We're seeing what happens when we haven't engaged and the degree to which we aren't being listened to, and it's scaring a lot of people within the academic institutions. But so one of the things I hope to do in my more private role now is to be able to take this out and work with others across the scientific endeavor, improving the understanding of how the political side works, the policy side works, and how to help us understand not to stop being scientists, but to understand the role of our cultural norms within the culture and how to modify it for going outside, because we really do just have to employ different communication techniques inside and out, and hopefully not just communicate, but activate by actually getting engaged and spending the time, and which is going to mean that we as the academic institutions have to support people doing this, to be able to get out there, because we're all in this together. So thank you. And do you want time for questions? Is there any questions? Yeah.
Well, so I'm curious about the thing you were saying about the earthquake scenario and how you kind of refuse to give them specific probabilities. I'm trying to think how we might apply that in working with stakeholders thinking about climate, because very often it seems like they want particular information, so we'll try to provide that.
Right. Yeah, and one of the problems is, of course, they're asking it from their point of view. And if it's solely communication and we give them the answer that we heard them ask for, maybe that isn't actually the one that's going to help them make the decisions. I started saying from doing media things, answer the question they should have asked, which is even more important with reporters, but it also can be within this situation. And sort of trying to understand why they're asking for those numbers and what they want to do with it. I think one thing that on the climate side is, rather than saying, here's the probability we're going to reach this temperature, it's going to be as these changes happen, we're going to be increasing the number of extreme heat days in Los Angeles by 40 to 60%. And the probability of where you end up within that really doesn't matter if you've given them a solid range that you can hold on to. And that implies 60 more days and how many, and even better, can you go to, the expected deaths that are going to happen for those increase of extreme heat days. That makes it real to them. This is how their citizens are suffering. And I think it's as important, it's to take it, we've got to support doing that work to take it to the full impact. And answer a question that gives them tools to respond, which isn't necessarily the probabilities. Yeah.
Thanks for your talk, it was great. I was wondering, because my initial reaction, you were talking about the importance of bringing a solution when you're talking about a problem, and relating this to climate change is part of the problem is that there are all of these proposed solutions, and it's unclear exactly which ones we should prioritize and things like that. But then I was thinking, with your plan, it was probably pretty similar, like with the earthquake.
Yeah.
So I'm wondering how you came to this sort of very tangible, this is what we want a retrofitting of these buildings. Was it through meetings with stakeholders?
It was a combination. So it began from that scientific study. And I actually think, and I've heard some talk of it being done. I mean, if we could do a climate change scenario that said, at 2050, here's a plausible scenario. And forget the probabilities of whether we're going to end up there. Pick the mean one that's, sort of expected course. It could be worse, it could be better, but here's the mean. and it implies these many people dying from these different causes. And really work that out, because what happened with the earthquake one, I was surprised at some of it I knew was going to be a problem. Like the whole thing of, one of the reasons we did a San Andreas earthquake is people don't understand that having an earthquake means the fault moves and everything crossing the fault's broken. And we weren't seeing that going into planning. And so we specifically put that as part of it, and then these are the gas lines that are going to break. These are the roads that are going to break. These are the aqueducts that are going to break. And make that concrete. And that's where, the same thing with, at 2050, this is going to be the temperature. These are the number of people dying from these causes, or this is whatever. And then, but I wasn't, some of it did surprise me. One of the things that came out of it was that the lack of water is the single biggest financial outcome, is that it's going to take up to 6 months to get water back to all our houses. And a small business that doesn't have water can't reopen. You can't open a beauty salon, a restaurant, or most manufacturing. And if they're out for 6 months, they don't come back. 6 months is sort of a, as you look, you can get economic data of how many businesses will be destroyed by not being able to reopen for this time. And we worked that out and came up with saying that the business disruption costs from the lack of water was $50 billion. Yeah, and I'm just like, I never would have imagined this. And that the total business disruption costs were equal to the direct losses in the event. So that what really matters is that economic outcome. So it both gave me, boy, we better focus on water. It also gave me a talking point for the business community about how it's really about their inability to get back to work. That helped them discuss it. And so I had that science as part of it. And then the other part, though, was really working with communities of, okay, so what is the solution? And if we could come up with a really good scenario of climate change outcomes, the thing is, it's probably something, do you do it regionally or do you do it nationally? I mean, there's all sorts of ways. This is the expected cost. And then engage the people who really have to be part of this policymaking, both the elected officials, but also the business community. Here are the costs in the long run. Here's the expectation. And what would be critical, though, if we do this, is we can't come up with this scenario and then have 20% of the climate change community in public shooting it down. Right? One of my friends in engineering talks about engineers conducting a circular firing squad. And they tear each other apart and then they don't get listened to because they do externally what they're used to doing internally, and they've completely undermined their credibility. So we would have to get that that climate change consensus. This is what the United States is going to look like in 40 years, in 2060, if we do nothing. And what degree can we change? And then you start having, we need to have some approach for really engaging the larger community and saying, we want to change this. If we could reduce carbon by this amount, we would reduce this number this amount. Okay, so there's your value to doing this. I don't think people properly understand the costs that are coming from climate change. It's going to making the changes now. But one of the things I see happening is people, because we don't talk a lot about the solutions, because there are so many that's also varied, people make up their own. And a lot of people think that the only solution is giving up modern life. That we're going to have to give up our electricity, we're going to have to give up our cars. And that sounds so awful. I'd rather think it's not true. And I think it really helps people reject the evidence because they have a pretty strong incentive to reject the evidence, and they're now being given the ways to do it.
Just playing off of what you were just saying, do you think it really has to be one scenario, or can't it be a series of scenarios that may be plausible? There's methods now to look at the solution space across a series of scenarios, several scenario-based planning and other, computational methods to be able to look at what solutions are robust across those scenarios, so that when you're making a decision to invest in something or mandate something, you can have higher levels of confidence that what you do actually implement is going to cover a larger space.
And I think that's what's needed, right? What you would want to be able to say is, if we do nothing, this is the cost to the United States. and whatever's necessary to get the scientists to not shoot it down, to come up with that. But then what should be presented? Here's the cost of doing nothing. Here's the cost of, here's the reduction in that cost if we successfully reduce carbon emissions by this level. If we can get completely carbon neutral by 2060, here is the cost of what it's going to be. And I think being able to make those statements, and every scientific field, I don't know enough of the details. I'm starting to, actually my son's just gone into climate science PhD, so I'm starting to learn a lot more. How to come up with those values. But that's the type of statement we need.
But in your experience then with the mayor's office, if you guys had more than one planning scenario, would that conflict?
No, yes, it would have. Because, and we didn't try to say this is the only earthquake that's going to happen.
Yeah.
We said there's lots of earthquakes going to be happening, but let's look at this one, because this is a really likely one, and if we handle it, there are 300 active faults in Southern California, right? And there are earthquakes that will be much more damaging to Los Angeles when they happen on the faults within the city. The value of the shakeout was, it was so likely because the San Andreas is the fastest moving fault and it affected so many more people. So we made a choice to pick the one, but if we had tried to do it off of others, it would get brought up in discussions, but it wasn't part of the fundamental messaging because it got confusing. And you can do that as long as it's how to phrase it in a way that our colleagues don't shoot us down. And the biggest problem is the fellow scientists, not the policymakers. Yeah.
So you, with your shakeout scenario, you have sort of a time horizon. You said, just give me long enough, and you will have an earthquake like this.
Right.
But with climate change, the time horizon is actually really important. So how do you sort of balance?
Right, so you got to pick which one you're going to go with to try and make it consistent, right? It's a different problem in that sense, because I also can't prevent the earthquake. And we could, it's too late to prevent it all, but we can make a really significant change in that. So in that sense, it's a different question. It becomes, and I guess it's like, okay, let's take a step back. What are we wanting to accomplish? We want to get policymakers to take action to reduce emissions, to reduce the heating. What's the information they need to make that decision? They need to see what the cost of doing it is, of not acting is, to weigh against the cost of acting.
I guess my thought is, though, that the farther out you get, the bigger signal you have, the more of a change will be, but also potentially then they won't listen to you. Like, I don't care what happens in 2100, right? So.
And I think that's right. So there's another psychology point to be made. We see it a lot in hazard science, is what's called the normalization bias. We believe that the things we're going to have to deal with are what we know about. And so if you haven't experienced it yourself or heard stories from your parents, maybe your grandparents, it just doesn't seem real. As an example, what do you think was the worst disaster in California history? It's not an earthquake. There was a massive flood in 1861-62 that bankrupted the state, destroyed 1/3 of the taxable land. Most Californians don't know it happened, right? And because it's just a little too far, and especially when we all moved in. I mean, I'm actually a 4th generation Southern Californian. We came in 1872. We missed that storm, right? It wasn't part of the family story. I had never heard of it when we started doing some research on it. So looking forward, I think 2100, the one thing is this, your children are going to have to deal with it. If you can say that. So a young person today, or 50 years, that's lots of people, either you're going to be living to see it or your children are. And I think you need it in that time frame to get the emotional connection. And probably regularly, our children will be getting this. Say it that way.
I was curious about striking the balance between answering questions that policymakers might have versus offering your own answers off the bat. And because when you mentioned the journalists
Answering the question they should have asked?
Right, and so kind of balancing those and offering, like your role is offering information versus offering information they might want, like how you...
Well, if you offer information they don't want, it's probably useless, right?
Well, that's what I mean.
Yeah.
In the
Right.
policy context. Yeah.
Right, in the policy context. So I guess I've evolved a process, and it's something you learn with time of dealing with people. And actually, one of the things we're going to be offering in the next round of these activation workshops is just mock and before we send people out to real policy offices, give them time to play act it a bit more. Coming in to offer information, one of the things is, as we as scientists have a huge value to policymakers in that we have information they think they need. And most of them recognize that. And the policy people we brought to Caltech last week, they were like thrilled over this. And oh my God, the scientists actually want to talk to us. So that was a significant issue. But it's usually a relationship process in which you right? So starting it off with, I have information that I wanted you to be informed about what we're doing on this because I think this would be useful for you. And then part of it is that aspect of how to develop the information. Part of it is going to be, like I said, to creating a different type of information that's going to be more accessible to them. I mean, I've seen stuff getting going about scenarios on climate change, and I think that's important. When I said answer the question they should have asked, I actually meant it after they've asked the question, and it doesn't make any sense. Because the reporter doesn't know what he's talking about usually. He's just trying to get you talking. And people try to answer the exact question they ask that doesn't make sense. They get just tied up into knots and end up saying ridiculous things, right? So that's one aspect of it, and it's going to happen some with policymakers. So it's like, it needs to be the information they want, but you need to use your scientific ability to put that filter in and say, they think they want this, but really what they want is this, because they don't know enough to realize that there's a difference. And I think our biggest problem is our literalness. They ask for this, and we don't think to say, well, I think you really want this. We answer this. And instead of I think that was what was really different of being in City Hall that was very different for me, besides being exhausted, was just they're making decisions. They're trying to do the best for the city. They are, not all, but at least with Mayor Garcetti's office, they were really driven as evidence-based. Right, that's his mantra, and so I'm providing them information on the side, one side of it, what the Earth is doing, or even what the buildings are doing. There's a whole other piece of making that policy result is what the people do, and they're the ones with that information, and that's why I think it's a working together process. And I met with his senior staff. We had a 20-person meeting every week for the whole year as we put these pieces together. And I think we're going to have to get to something like that. My guess will be actually that either in 4 or 8 years, or 2 or 6 years, we will have a president that says, we've got to deal with this. And there will be federal level really task force. And I just really hope that we figure out how to get the science in a form that's really accessible to the other, the people who have the other types of information. Yeah.
I work with Alex Holliday, Center for Climate Science here, and we're trying to work in this science activation space that is a militarized zone. And one of the barriers that we come up against, or a challenge, I should say, something that you talk that there's not a lot of support within academia to free up faculty time or give other resources. And it seems like you've had some success creating some resources at Caltech, and I wonder, thinking of the university as a communications audience, how do you talk with them how do you talk with academia in the language they understand to sort of justify these activities and get support?
It's a challenge. You've got to find the person with the light behind the eyes in the position of power. And there's more of them coming along. The other thing that just happened at Caltech with this round is that the students asked for it. One of the things that I started realizing is that there are a bunch of different initiatives that are happening driven by students, the faculty sort of going, oh, really? And and they don't know each other because they're all in different parts of the institute. And but the generations are changing really fundamentally, and I said, I think driven by climate science and the recognition of what it is. So I would advise you to look towards the younger people in decision-making places to recognize that option. But also, you can contact my center if you want, and we can, talk about how to be able to support doing more of this. The other one really encouraging thing, and this might be a piece to sort of prod at them, the National Academy of Sciences is got a committee. The problem is they take forever to do anything, but they are creating a guidelines for academia of how to evaluate policy work in tenure decisions as an explicit thing of honoring that type of work as an important part of the role academia plays. And I think once the Academy comes out with that, this is being driven by Marcia McNutt, who's the president there. I think that will help a lot, and just prodding them that it's coming. And I'm not quite sure when. Marcia told me about this, God, when did I see her? In May. So almost a year ago. So I'm sure it's not done yet, but maybe it's within, and maybe it'll happen this year.
You didn't mention it, but I wanted to bring up, if anyone's interested in gaining hands-on experience with the science and technology policy making in the federal government, the AAAS, American Association for Advancement of Science, has a Science and Technology Policy Fellowship for PhD scientists. And also the California Council on Science Technology has a similar fellowship that works with the state senate and state assembly, so that those are ways. And what I've seen in the past for people, for example, going to work as fellows at the NSF, they bring back that knowledge of the grantsmanship process and all, and that helps inform their college and their university. And so universities find that useful, and you may take a stop time in your tenure process, but it can be useful information that you might use in the future.
Yeah, and universities tend to support the ones that improve the grant-making ability more than the policy side. But maybe we can get, everybody's, I think we're at a time of transition where there's more recognition that this is needed. And I guess what I want to say is, let's look at what have been the barriers, and let's do a better job of trying to address them.
I wanted to thank you for
Yes.
your wonderful talk, but I just had a very quick question. So there's a big difference, of course, between climate change and earthquakes, which is that we're all thinking of earthquakes as an act of God, right? So there's no blame associated with this. Whereas climate change, I think, has a lot of blame that goes with it. We're always thinking of it as man-made climate change and things like this. And I'm wondering if it actually, by refocusing the debate on just the consequences, I mean, whether that's man-made or natural or whatever the process is going on, just focusing on the consequences of that process and saying, well, by reducing emissions, we can actually mitigate whatever it is, whether it's man-made or not, we can avoid the blame question. And I'm wondering how much of that actually has to do with resistance to climate change.
I think it contributes to it. I don't know if we avoid things that are terrifying, and we avoid things that tell us that we're bad, right? And so both of those would encourage you to think that climate change isn't actually happening. And I do think focusing on the impacts, sort of whatever the causes, if we add more carbon, it's getting worse, right? It helps. And the reality is on earthquakes, I can't blame a human being for the earthquakes unless you're in Oklahoma. But I can blame people for the consequences. And that's actually, I think, been one of the challenges of dealing with the building thing. Your building is bad. Your building is going to kill people. And what I found, the interesting part is it's a lot easier to say that his building is bad, right? And so really, I think the reason we got this through was pointing out that when a building is red tagged, all of the surrounding buildings will be red tagged as well because of the potential that the damaged building will collapse on them during aftershocks. So your building may be fine and you'll lose the use of it because your neighbor didn't retrofit. And that aspect, I want to make sure, damn well sure he has to do it, and I'll put up with doing it myself to get it done by him. That really, I felt, was like one of the successful arguments with the business community. And I don't know if we can take that one into climate change. But I mean, that's actually sort of one of the things that's used as a reason not to do it. Well, China's still putting out this stuff, why should we? Right? And we have to get past that argument. And, you know, again, some of these concepts, you know, if we did this, this is the outcome and how much it would shift. And not just if we take this action, we reduce this amount of carbon. If we take this action, this many people won't die from heat exposure. I think that we've got to be able to make that connections to personalize it. So, well, one more.
Well, I just wanted to mention that there is a pretty good series of documents that try to produce these kinds of scenarios. The America's Climate Choices 5-part study by the National Academy.
And are they accepted as consensus?
That's the problem I actually wanted to bring up. Because I think we'll have a real hard time coming to consensus because it's such a messy problem. And there's some people who are very much invested in producing some false information, whether they're funded by or just fundamentally
All right.
because of their belief system. It really causes a lot of trouble. And if you have any advice on how to create consensus and work with those people or work around them, I'm interested.
It's so much bigger a scale than, of course, what I've done individually, that's hard. But I think the most important lesson, and it was hard for me, is I wanted to not include the people that were painful. Engaging them early turned out to be the right approach. You know, so I wasn't going to get this to work if I didn't get the Building Owners and Management Association to accept it. And I went to meeting after meeting after meeting with them. And we got there, right? Because they're people too. When you get in there, even though, you know, if you get in, and part of it is how to enter a dialogue that's a dialogue and enter a dialogue that respects the emotional issues that they're dealing with. Right? Keep absolute about what's science. And, you know, that's probably the hardest part is, and I still have colleagues that will tell me what's wrong with Shakeout, you know, but one thing I discovered through the process, we had people complaining we co-opted them, asked them to be part and contribute to it. And yeah, right, it's painful. But then there was no one left to fight us at the end. It's hard though. Especially for a natural introvert. I've spent a lot more time in bed after having to do this during the day. Yeah.
So I feel like you're saying there's just no way to marginalize those people. And from a moral perspective, it's not right to marginalize anyone. But on the other hand, is it ever effective to say those are the 5%? Can you not see that can you, world, not see that 95% of this community agrees, and it's only these 5 very loud percent that disagree?
Well, number one, they're loud, and number two, the public has a huge stake in listening to them. We've got to take away the incentives for the general public to want to listen to the 5%. And I think that they offer them a way out. They offer them a way to not have to deal with the problem, right? And, you know, we've already, you know, it's already too late, right? We're already seeing some pretty direct consequences. The more we can be clear about the connection between climate change and our fires, climate change and the intensity of hurricanes, that helps, because those are things that people look at and go, oh, I get it. This is what's happening. And start, you know, and that's, we're looking at the consequences, we do a lot of talking about sea level rise. That's really abstract to a lot of people. And I can't, I did some work with a group that was working with Charleston. They call it, what is it? There's nuisance flooding. This is sea level rise. The ocean's coming into your damn house. But it's nuisance flooding, and they wouldn't talk about it as anything else. So sea level rise seems to me to be a really hard one for the public to engage with, whereas people dying because of the heat and cities destroyed because of more intense hurricanes. Those are concrete, where you can feel the impact. And I think that in terms of giving people a reason to not listen to that 5%, we both need to be sort of clearer about what's really at stake to the degree that we can, but also offer them more positive solutions. I think as long as people see the solution as giving up modern life, they aren't going to listen. When we can present the solution as really embracing renewable energy, why do we want some other country to have that technology? Don't we want to be the ones that do this? I think it's the messaging rather than the content, and that's, again, that's really difficult for us as scientists. Things are supposed to be true or not true. It shouldn't be about how you present it, but it is in a human world. And on that note, thank you.